This lesson starts off with your steps on how to solve a radical equation. And the first step is to isolate one radical on one side of the equation. So what I mean by that is this one has one radical isolated where you have just the square root on this side. This one, however, is not isolated because you have the square root plus 6 not in that square root. So we want to get it into this form here. Then we will raise each side of the equation to the power equal to the index of the radical and simplify. Now, for us, we're only going to be using square roots. And we learned last lesson, when we went over the square root method, that the opposite of squaring x is to take the square root of x. Well, now we're doing the exact opposite. To get rid of this square root, the opposite of the square root is to square. So we're going to square every side. But this works for anything. So what I mean by the power equal to the index is if this was a cubic root, we would cube both sides. If we had the fourth root, we would then take each side to the fourth power. So you want to match that index to whatever power you're using. Step 3, if the equation still contains a radical term, you need to repeat steps 1 and 2. If not, solve the equation. And that's only going to come into effect on our very last problem. And then step 4, check all proposed solution in the original equation for extraneous solutions. A lot of times when your instructions say to check your answer, that's to make sure you did it right. This is a step. You cannot skip it. We're going to check all solutions into the original equation for something called extraneous solutions. So the first part of this word extraneous is extra. Sometimes we're going to get extra solutions that are not actually solutions. We're going to solve all of these problems correctly. We're going to go through the right steps. But then when I substitute it back in, it does not work. So we have to check it. Okay, so examples. Number 1, we're solving radical equations. So step 1, isolate. We already talked about that. That is isolate. You have just the square root. So now we're going to raise each side of the equation to the power equal to the index. Because this is a square root, we are going to square both sides. So the square root and square cancel, and I am left with 3x minus 4. 5 squared is 25. Now I have a linear equation because we just have x, so solve like normal. We're going to add our 4 over and then divide by 3. So x equals 29 over 3. Now typically this is the part where I circle or box my answer in some fashion. But step 4 says to check, and we must check every time. So I'm going to come over here and I'm going to check my answer. I'm going to plug my x into my original equation. So we have the square root of 3 times 29 over 3 minus 4. And I'm wanting to know, does that equal the right side? In this case, does it equal 5? So work this out and simplify it. 3 divided by 3 cancels out. So we're left with 29 minus 4. 29 minus 4 is 25. So we have the square root of 25 equals 5. And is the square root of 25 5? Yes, it is. Okay, and if you want to, you can take it the next step and say yes, 5 equals 5. But either way, however far you need to get to verify that it does work, now we can come over here and say, yes, this is my solution. But I cannot circle or box it or be done until I come over here and check my answer. Okay, so number 2, we need to isolate first. So we have a square root plus 6. I need to move this 6 over. So I'm going to subtract it over. to get the square root of 5x plus 4. And now that's going to equal -4. So now I need to square both sides because the opposite of a square root is to square. So my square root and square cancel each other out. I'm left with what's under that radical, 5x plus 4, and -4 in parentheses squared is +16. Now we have another linear equation here because it's just x. No x squared, x cubed, x to the fourth, just x squared, or just x. So subtract your 4 and then divide by 5. And x equals 12/5. Now before I can circle or box, we've got to come over here and check. So I'm going to plug in 12/5 for this x here. So we have 5 times 12/5 plus 4 plus 6. And I want to know, does it equal the other side? Does it equal 2? So 5/5 cancels again. So I have 12 plus 4 plus 6 on the outside. That's going to give me 16. The square root of 16 is 4. But 4 plus 6 does not equal 2. So this is not my solution. This is extraneous. And because this was my only possible solution, and we have determined it doesn't work when I substitute it back in, then that means this one here has no solution. Okay, there is not a number I can plug in for x to make that equation true. Now, there is something very different between these two that I can kind of know that this is going to be extraneous before even really plugging it in and checking it. And the difference is when I squared this one, I was squaring a positive number. When I was squaring this one here, we were squaring a negative. So when I get to the square root equals some negative number, I can stop right there and say that's a no solution. Number 3 looks really complicated. It's even easier than the top two, in my opinion. This is to isolate, step 1 is to isolate one radical on one side. Well, this radical is isolated and this one's isolated. They're both isolated. So to get rid of those square roots, I'm going to square. And what's going to end up happening is this square root and square cancel, leaving me 5x plus 3, as well as this square root and this square, leaving me 4x plus 5. So subtract your 4x over and subtract your 3 over. And we get x is 2. Before I am done, I need to check this. So into the original, we'd have the square root of 5 times 2 plus 3. And I want to know, does that equal the other side of the square root of 4 times 2 plus 5? I'm plugging this x into both x's. So I'm just going to simplify this side first. We have 10 plus 3, which is going to give me the square root of 13. And we could get some decimal, but not necessary. Over here, we have 8 plus 5, which is also 13. So we do have the square root of 13 equals the square root of 13. So yes, this is our answer. Let's go on to the next page and solve number 4, and then we're gonna take a break before this video gets too long. This is still the same type of equation, but it's wrote in with rational exponents. So there's some property that says if we have x to the m over n, whatever's in that denominator comes around and becomes the root. And then this numerator stays as the exponent. So here, this 2 is going to come around to become the index, but I don't really need a 2 there. So that's just the square root. We'll have x minus 8, and that's all to the first power, so I don't need an exponent of 1. So x minus 8 to the 1/2 power is the same as the square root of x minus 8. And then we have plus 10 equals 7. So now it looks the way the other ones did. The first step is to isolate. So I have a radical plus 10. Let's subtract that 10 over. And we get x minus 8 equals -3. And that should, ding, 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 ring a bell. Because this square root equals a negative, this means no solution. So if you can recognize that, it will save you a little bit of time. If you don't recognize it, what do? You're going to do exactly what we did on problem 2 here. And you're going to work it out and get to your answer. And when you plug it in, you're going to realize it doesn't work. And so then you're going to know it's no solution. But if you can recognize when this square root equals a negative number, I can stop. That's going to be a no solution.